Imagine you're inside a machine the size of a small car, traveling farther from home than any human has ever been. And the machine punches you, not metaphorically, literally. A bang, a shudder, gauges twitch, lights flare, and the void outside your window, pure, indifferent black, suddenly has something new in it. A glittering cloud, your ship, is leaking itself into space, and you do the most human thing possible. You call home, and you try to sound normal. Okay, Houston, we've had a problem here. That sentence is the birthplace of modern crisis engineering. Not because it was poetic, but because it was understated. Because underneath that calm radio voice was the most terrifying truth a complex system can reveal. The failure you trained for is not the failure you got. Welcome to Apollo 13, NASA's successful failure. Here's the strange idea we're chasing today. Most people think Apollo 13 is a story about bravery. It is. Most people think it's a story about duct tape saving astronauts. Also, yes, duct tape shows up like a side character who steals the whole movie. But the deeper story is this. Apollo 13 became a template for how we run anything high stakes today. Aviation safety, ICU protocols, nuclear operations, cloud reliability, incident command, cyber response. The entire discipline of how to not die when systems failed at NASA didn't just bring 3 astronauts home. They turned panic into procedure, then exported that procedure to the future. Oh, I'm going to take you deep into the rabbit hole. But I'll leave trail markers like reflective tape on a dark cave wall. Trail marker system. Keep these in your pocket. Trail marker 1. Complex systems fail in weird ways. Trail marker 2. Stabilize. Then optimize. Trail marker 3. Make reality legible. Telemetry into meaning. Trail marker 4. Constrain the problem. Time. Power. Oxygen. Trail marker 5. Turn improvisation into repeatable steps that you'll hear those again. That's the trail. Apollo 13 launched on April 11th. 1970. It was supposed to land in the From Morrow region of the moon. And here's the first psychological twist. By Apollo 13, moonflight had started to feel almost normal, which is insane. Like saying, yeah, I commute through the atmosphere. Traffic was light. Networks didn't even carry parts of the broadcast live because the mission seemed routine. Until it wasn't. Trail marker 1 appears. Complex systems fail in weird ways, especially when humans start believing they're not dangerous anymore. Because routine is not the absence of risk, that it's the presence of complacency. Now meet our cast in this pressure cooker. Jim Lovell. Commander, Fred Hayes, Lunar Module pilot. Jack Swigert. Command Module pilot. A late replacement, they're riding a stacked tower of controlled explosions, on the way to a rock that doesn't care about them. With exactly one plan: land, explore, leave. Then, mid-mission, Mission Control asks for something ordinary. Stir the oxygen tanks, which is like saying, hey, jiggle the gas can. About 56 hours into the mission, oxygen tank number 2 is stirred. A bang follows. The crew reports undervoltage alarms and trouble. The now famous line is recorded in mission transcripts. Important detail. The iconic pop culture quote, "Houston, we have a problem," is a later misquote. The real-time wording was, "We've had a problem." And here comes the system's nightmare. Those oxygen tanks weren't just for breathing. They fed the fuel cells that generated electrical power. And water.S01 failure cascaded into multiple domains: life support risk, power generation risk, propulsion and navigation constraints, thermal issues, and the big one, time. Trail marker 2 appears. Stabilize. Then optimize. But first you must answer the most terrifying question in engineering. What kind of problem is this? Is it instrumentation lying? A transient glitch? A slow leak? Or catastrophic structural damage? Lovell looks out the window and sees oxygen venting into space. Reality checks the telemetry. Now the mission objective changes in one sentence. not land on the moon, not even return the spacecraft. Just this: return the people. This is where the story becomes a masterclass that NASA didn't solve one problem. They solved a stack of problems under brutal constraints: power, fuel, cells dying, oxygen, venting, and consumption rates, carbon dioxide buildup, CO2 poisoning, risk, navigation, how to get home, heat, freezing cabin and battery, limits, reentry. The command module must wake up and not kill everyone. That's not a fix the car situation. That's a rebuild the car while it's falling off a cliff situation. Here's the move that saved them. They power up the lunar module and use it as a lifeboat. But the lunar module was designed for 2 astronauts, not 3 people for a long, cold ride home. This decision is pure crisis engineering. Take a component not designed for the scenario, stretch it beyond spec. Manage the risk explicitly. Trail marker. 4 appears. Constrain the problem. Your resources budget is measured in amp hours. Water, oxygen flow, CO2 scrubbing capacity, and minutes of trajectory margin. Now comes the famous duct tape moment. Except it's more than acute. Anecdote. CO2 levels rise because the lunar module's scrubbers aren't enough for 3 people. The command module has extra canisters, but they don't. FIT.SO engineers design an improvised adapter on the ground, test it, and send instructions up. A jury-rigged mailbox lets command module canisters scrub CO2 in the lunar module. And yes, duct tape becomes legend. But the real miracle isn't duct tape. The miracle is this sequence: design, test, procedure, execute. Under time pressure, trail marker 5 appears. Turn improvisation into repeatable steps. Then power becomes religion. Apollo 13 must preserve command. Module batteries for reentry, parachutes, and communications to SO. The command module is powered down hard, minimal systems. Every what matters. This is a controlled descent into dormancy, keeping just enough alive so the spacecraft can resurrect later. Modern parallel? A black start in a power grid, disaster recovery in cloud infrastructure. ICU triage under scarcity, stabilize, conserve, survive. Now we go deeper, but I'll keep the trail lit. Investigators trace the accident to oxygen tank number 2. A chain of damage. Overheating, an electrical failure leads to insulation breakdown and a short, triggering fire and explosion. A key factor: the heater system wasn't properly matched to a higher voltage ground test configuration, contributing to overheating. This is the real villain of Apollo 13, not space, not bad luck, but a classic complex systems failure, a mismatch between assumptions and reality. Hidden until the worst moment. Trail marker 3 returns. Make reality legible. Telemetry is not truth until it's interpreted correctly and checked against physical evidence. The crew swings around the moon to return home. The destination becomes the tool that saves them. In crisis engineering, we call this reframing assets. The thing you lost becomes irrelevant. The thing you still have becomes everything. Apollo 13 splashes down on April 17, 1970. Only then does the world exhale. NASA later calls it a successful failure. The mission failed its objective, but succeeded at the higher objective: crew survival and rapid safety improvement. Now let's make the claim we opened with. Apollo 13 didn't just get solved. It got systematized. NASA absorbs the event into redesigned hardware, improved testing, tighter configuration control, and updated contingency procedures. This is the engineering move that changed the world. Convert a one-time rescue into institutional memory. That's modern crisis engineering, not heroics. Repeatability, training, humility. The assumption that you missed something. Translate Apollo 13 into today's crisis language. 1. Incident command. Define the problem. Assign roles. Maintain a single source of truth. Avoid chaos. Point 2. High reliability thinking. Don't try to never fail. Fail in a way that leaves options, redundancy. Cross-checks. Simulation. Obsession with constraints. Point 3. Successful failure as a design goal. Graceful degradation. If X fails. Drop capability Y. Preserve capability Z. Survive. Point 4. The culture lesson. Remember, failure is not an option. Popularized later. Not spoken that way in real time. Stories become operating systems. Mythologize the wrong thing. You train the wrong instincts. The real Apollo 13 motto wasn't a slogan. It was method. Stabilize, conserve, interpret, constrain, proceduralize. Apollo 13 wasn't saved by luck. It was saved by philosophy. Respect complexity. Treat time and resources as math, not vibes. Make decisions legible and reversible. Convert chaos into procedure and the deepest truth. The best crisis engineering happens before the crisis. In training, in design reviews, in people obsessed with edge cases everyone else calls paranoid, because one day, the system will make that sound, soft hum, distant bang. And when it does, you don't rise to the occasion, you fall back to your preparation. That is the secret. Apollo 13, handed to the modern world. NASA called it a successful failure. Engineering calls it a blueprint for survival. If you want more stories where failure becomes the teacher, subscribe and tell me in the comments. What modern system is one Apollo 13 moment away from rewriting its own rules?